In this video, I want to talk about findings. Now, these are all theoretical, and these aren't. Some of these ideas are not fully based on truth, on reality. A lot of this is speculative. I guess you could say flim flam to a small degree. But I'd also like to point out that everything in this video is comedic. It's a comedic video. It's a comedic take on nuclear weapons and how powerful they can be made. So this is all comedic, and it's also intended for it's educational as well as being comedic, and it's for educational purposes, of course, and it's all speculation. None of this is based in reality totally, and it's all just speculative and comedic, and to a small degree, educational, informative. And so, with that being said, with that out of the way, um, I have been using different technologies, different tools, and I'll be vague about that because, I don't want other people stealing my ideas. But I've been using different tools to, in theory, develop, on paper, in theory, develop new types of weapons. Extremely potent opioid, potential weapons. Neurotoxin technologies. And thermonuclear weapons, and this is because of my intrigue in such things, and none of it is nefarious. It's all just fascination and interest. That's all. But I'll make a separate video on the neurotoxins, because I want this video to be about at new highly advanced thermonuclear weapons, in particular subatomic weapons and thermonuclear weapons. And I'm sure you've never even heard of a subatomic weapon before. I'm sure you've heard the term subatomic or atomic, but subatomic weapons are a whole new field, which I've discovered. I haven't even come across almost anything at all about it. Now, I saw a post years ago about a Higgs boson weapon, a Higgs boson nuke, and this is as much as I had found. There also were speculations about splitting subatomic particles like photons, or what was it? No, protons or electrons, but nobody deeply speculated from what I saw on subatomic weapons, and so with different research tools, I was able to create, in theory, a design for a new type of nuclear weapon, a subatomic weapon, which that's not even nuclear. It's not even nuclear. It's something far beyond that. But I think I'll talk about that first. First, I'll talk about subatomic weapons, and then I'll talk about super heavy thermonuclear weapons, which is a more complicated one, I think, than subatomic technology. Subatomic technology is more complicated, but it's easier to explain, I feel like. So I'll talk about this one first. From the research I've done, with the tools I've used, what I've learned is that you could focus a beam of energy. Now, visible light, focusing a beam of light like a magnifying glass, and sunlight, it would not be effective to create such a weapon. It would not be functional at all. But what I found is that you could create, in theory, a massive thermonuclear weapon, a huge one, and it would have to have a very specific design, called a layer cake design. It would have to be a complete sphere. And everything would have to be in layers. There can be no separate stages. Everything has to be in layers, in a sphere of layers, like the Earth and its mantle, you know, the crust and mantle and core and all that. It has to be layered like that. And if it were designed in any other way, it would be completely ineffective. And so basically, you know, I've already made this video actually 5 other times because I go into too much detail, and I'd start construing, you know, mixing everything I'm saying together, and you know, it's so hard to explain all of this, you know, in an easy way. But basically, the thermonuclear weapon would ignite the, you know, the explosives would compress the plutonium, uranium, likely plutonium, whatever. Then um, that would send a bunch of energy, a bunch of particles into different materials that would compress, you know, like hydrogen, deuterium, tritium, whatever. Create fusion. It would cause fusion, and then from there, the fusion, you know, would produce even more energy. Now you have to put a lot more energy into fusion in order to create new elements compared to fissioning. It takes more energy to create than to destroy matter, but you get more energy out of creating matter. So you get more energy out of creating matter than what you have to put in. You know, at least when it comes to producing, you know, particles. And so from what I've learned, with the tools I've used, basically you could create a thermonuclear weapon that you know, causes fission, then causes fusion, and compresses, you know, hydrogen, helium, tritium, deuterium, all that, whatever, and it compresses it, and then releases tons of energy, and then from there you could, it would produce far more light. It would be extremely bright, and all that energy could then go into these tubes, these you know, tubule structures that, you know, they would have to be super cooled, and they would have to be made of pure diamonds. Well, actually, no, not diamonds, because those are very heat. They're very heat conducting. But it would have to be made of some sort of ultra heat resistant, super hydrogen, liquid hydrogen or solid hydrogen super cooled material, because every picosecond counts, and this would be an extremely quick event, you know, far quicker than the blink of an eye. And all this energy from the fusion event in the almost the core of the weapon would direct energy. It would direct energy through these lenses that would magnify the light. It would direct the light into like a very small beam, you know, on all sides and all directions around this sphere. So if you can imagine a sphere of magnifying glasses directing light into a little pellet, and this pellet would be at the very core, the very center of the weapon, and this pellet would basically contain, you know, very dense material. It would have to be very dense at the start to make sure you have a higher probability of hitting a subatomic particle. And basically the element, you know, let's say it was something very dense, like what's the densest? Osmium. That's the densest element. It would have to be an osmium pellet, you know, a perfectly, absolutely perfectly circular, extremely down to the nanoscopic level, a perfectly spherical pellet of osmium, and all the light energy, all the visible light and infrared light and X-rays and ultraviolet rays and microwaves and radio waves and gamma waves and neutron radio, everything would have to be directed by these lenses, these quote quote magnifying glasses. It would all be directed, you know, and ultra magnified, right at this little pellet of osmium, which is a metal. It's a very dense metal that weighs a lot, even in small quantities. And so the light would be directed onto the osmium, or not just the light, just all the energy, all the magnified energy would be directed at the pellet on all sides, squeezing it, condensing it, and turning it into plasma. Now this of course would make it even less dense. It would heat the element up, and the element would transmutate from all the particles hitting it, and it would become extremely dense, and then at one point it would turn to plasma, pretty much instantly. Actually, pretty much instantly it would turn to plasma, and it would become less dense. But from all the energy being focused on it, the plasma would start to harden in a way. It would become a solid plasma in a way, a metallic plasma, and that's theoretical, by the way. No proof of that. But basically, the plasma would become, this super hot, super bright, metallic, perfectly spherical object, and it would condense, and the beams of light would split the subatomic particles within the atoms of the osmium, well after it transmutates into other elements, and the subatomic particles would split apart. They would hopefully, I doubt this would even be possible because of, if I'm correct, the strong nuclear force and the energy contained within the particle. It would be very difficult to shred them apart with heat, or cut them in half with an energy beam. But in theory, you could split the subatomic particles apart and release massive amounts of energy. I'm talking what is it, teravolts, teravolts, petavolts, likely hundreds of gigavolts per particle, because they would become super top heavy. We're talking like millions, billions, trillions of top quarks, and yes, it would take a lot of energy, it would take a lot of material and a lot of energy to produce these beams to split these subatomic particles. But you would get way more energy out of it than what you put in, because of the magnifying, the focusing of the beam energy, on all sides from different, like, magnifying lenses. Now, developing such advanced magnifying lenses to resist the heat, just from the particles hitting it before the massive heat waves, and the kinetic energy, what is it, kinetic energy, the shock waves, pressure waves. I mean, it would be extremely difficult to design such a weapon. But if everything were done perfectly, I think that it could be possible to split a subatom, extremely small subatomic particles like quarks. What are they? Quarks, leptons, gluons. What, I haven't looked into it much. I've been using other resources to figure these things out, do the research. I'm just learning about the resource, what the resources come up with. I'm not coming up with this, not fully, of course. I just come up with the theories, and then the resources develop the ideas in detail. How it could be achieved in theory. So this was the first advanced subatomic weapon design. There was another I came up with, but that one is still in the works. Another type of weapon, because a subatomic weapon is not nuclear, it's or thermonuclear or whatever. It's completely different. But a thermonuclear weapon, a super heavy thermonuclear weapon, is another design that I in a way came across, and this would involve the creation of actually many nuclear weapons that would act as a trigger, as a starter, as a way to boost jump. What's the word I'm looking for? Kickstart the thermonuclear ignition, I guess. I can't think of the right way to explain it, but basically it would involve using many nuclear weapons surrounding a core of highly dense material, and basically each of these nuclear it would basically be like a regular nuclear weapon. Picture not a thermonuclear, but picture a regular nuclear weapon, and how it has all the insensitive high explosives, all the IHEs around the sphere. You have like the core of the weapon, the plutonium or uranium, whatever, and then all around that you have all these you have like C4 all around the sphere, a perfect sphere of C4 built around the plutonium or uranium. And basically it would be like that, but instead it would be basically a sphere of nuclear slash thermonuclear weapons that would be in a perfect sphere built around a core of highly dense material, heavy elements. And basically, how this weapon would work is the explosives in each of the thermonuclear kickstarters would go off. Then the fission and the thermonuclear charges would go off. Then that would produce the energy needed for fusion, and then the fusion would go off all around the sphere of this weapon, and then that would cause massive compression, massive amounts of energy and compression that would go into the core of the weapon. Now there are three problems. There are three main problems with this weapon, and that's why it's theoretical. First problem is the energy that would go outward, the energy that would be wasted on the weapon expanding outward. If for instance you had gunpowder, that was out in the open and you lit it on fire, it would explode, yeah, and it would make a little blast. But if you put gunpowder inside, let's say a little steel ball or whatever, a little piece of aluminum foil, it would be compressed, and it would explode. It would rupture with more force because it would be trying to get out of that metal shell. And so basically this new thermonuclear weapon would have to be underground, or surrounded by a lot of very dense material. It would likely have to be very deep underground, and piled on by millions of tons of material, or perhaps just held together with some sort of extreme compression technology. I can't even think of what it would be, but it would need to the thermonuclear weapon would need to be compressed before it even goes off. It would need to be compressed by a massive amount of material and pressure. That way all the energy gets forced into the core, forced into the center of the weapon. But basically, yeah, it would be this sphere it would be a weapon surrounded by individual thermonuclear weapons, surrounding the core of this giant thermonuclear weapon. So it would basically be like several dozen thermonuclear weapons surrounded by, this complex thermonuclear core. But anyway, besides that, the other problem with the weapon would be the shock waves. Unlike C4, the shock waves produced by a thermonuclear weapon, from the research I've done, would be extremely unstable. They would be very erratic, and the way that, and I've studied how air interacts with nuclear weapons, and how whenever they go off, they'll like travel down power lines, and they'll produce lightning, and their shock waves will be kind of chaotic, and it'll interfere with the environment around it, and strange, interesting ways. And so the shock wave of nuclear weapons would make the core of this super heavy thermonuclear weapon highly unstable. And so the weapon would have to be designed in a way somehow to where the shock waves would be less unpredictable. And this is a problem. This weapon would have to be in a very unique environment, and it would also have to be probably massively tweaked in some sort of insanely a complex way. I'm not a nuclear physicist, so I don't know. But I'm sure there might be a way to make a thermonuclear shockwave more stable, less chaotic. Especially, it would be especially more difficult if you have dozens of thermonuclear charges surrounding a core of heavy material. That would be very difficult. But let's say it worked. Then the next stage would be the thermonuclear weapons sending the shock waves, sending the energy, the waves of energy and the particles into the core of the weapon, which would contain, a very dense, not just dense, but a very heavy and unstable element. In particular, something like einsteinium or francium, which are, technically, if I'm correct, super heavy elements. And, or at least I think francium is. And these super heavy, these atoms would be small. And this is where one of the problems comes in with this super heavy weapon. It would have to be huge, because the core of the weapon would have to contain a large amount of super heavy unstable material, or heavy transuranic material, and that would require more compression, more energy in order to fuse. But basically, there is a way. I've used some tools, some navigational tools, and I've been able to learn that you can actually put a substantially large amount of einsteinium in a small area. You could actually place several hundred kilograms of einsteinium into the core of a thermonuclear weapon without it becoming supercritical, unstable. And it's a complicated process, but basically, I'll keep my findings about that to myself. Theoretical, comedic findings, of course. They're all speculative and stuff. But basically, it is possible to compress literally hundreds, if not thousands, of pounds of einsteinium together into a perfect sphere, a perfect metallic sphere. Now the heat would be extremely difficult to control. That's one problem with it, but it could be designed in a way to where it doesn't go supercritical, and it doesn't produce too much heat to where it melts. This would be, an extremely difficult thing to achieve, but it is possible from the research I've done. And there would have to be a small amount of space in between the thermonuclear charges and the core of the weapon, a little bit of space in between, to allow for the shock waves to sort of, steady themselves, if that makes sense. But basically, once the core of the weapon being einsteinium, it very likely specifically has to be einsteinium. And, so once the shock waves hit the einsteinium core of the weapon, the perfect sphere of einsteinium, then it'll compress the einsteinium, and the einsteinium will go supercritical, and the compression will be so quick, and there will be so much energy that hits the einsteinium that it fuses into even higher level super heavy elements. I don't remember if einsteinium is. I forget. I don't think it is. But it will produce super heavy elements, like darmstadtium or moscovium, something like that. Probably not moscovium, but it could produce something like darmstadtium, and this would lead to a unique, likely theoretically unique event involving subatomic particles. And from what I've learned when it comes to fission and fusion, there's a lot of energy that's lost in heat. 1/3 of all the energy in nuclear weapons is lost in heat, and on top of that, only 1 to 2% of the matter, I think it's up to 3% of all the matter in a nuclear weapon, is converted into pure energy, subatomic particles and waves of energy. And so, like for instance, let's say Tsar Bomba, that used what, 3% of all the matter that the weapon was made of, or at least just the uranium, plutonium in the weapon. I can't remember, but if you could use let's say 100% of all the, or realistically, let's say 50% of all the energy in the core of this theoretical super heavy nuclear weapon, thermonuclear weapon, you could produce a substantially much more massive explosion from it. It requires more energy to produce more energy. Like everything that I studied, it requires more to get more in return. To get like tenfold, 1,000-fold more in return. But basically, the more powerful you make the weapon, the thermonuclear weapon, the more you get in return, actually. And so, if you had a thermonuclear weapon the size of the sun, you probably get more than 3% of the energy back from such an explosion. At least that's my guess from theories I've looked at. Um, but it also depends on the design and the type of material and timing and yeah, blah blah blah, a bunch of stuff. But in theory, you could compress Einsteinium into super heavy elements. Now, the core of it would have to be, yes, pure Einsteinium, but also on top of that, hydrogen. Because what I came across from the tools I've used, you obviously can't take two uranium atoms and fuse them together and get element 194, because two element 92 atoms combined equals 184, element 184, and that's not really possible. At least I highly doubt it. And so, with that being said, this Einsteinium core would have to be made of Einsteinium and hydrogen, and perhaps helium as well, so that the atoms could take in lighter elements and transmutate at an extremely high, extremely quick rate. And here's what I learned. Here's the trick of it. Stars release, they waste massive amounts of energy. This is just, for those that don't understand it. Stars release massive amounts of energy creating new elements. Just creating hydrogen and helium requires massive amounts of energy. And so you already have that energy contained, especially within iron. Iron. There's a special secret I've discovered about iron. I'll make a video on that someday. But elements that require massive amounts of energy to create, especially like uranium or plutonium in stars. Giant magnetars, which are, I think, technically neutron stars. Stars release. They waste massive amounts of energy to create heavier elements, like different types of metals, like gold, and uranium, the stuff we use for energy. And so, if stars already waste massive amounts of energy to produce things like uranium, then if we could add even more energy to the uranium, then we would get far more out of it. Putting in tons of energy, and the more you put into that element that already had a bunch of energy put into it by a massive freaking star, or a really small one that contains more energy than an entire galaxy, then yeah, the more energy you put into that element, the more you're going to get out of it in return. And it's sort of like investing in a way. Think of nuclear energy and nuclear weapons as investing. I think once you understand that concept, you could probably go down the path to making almost anything. But like I said before, I'm not a nuclear physicist, so this is all just speculation from research I've looked at, theories I've looked at, my own little theories and such. But you would already have a massive amount of energy in the Einsteinium core of the super heavy thermonuclear weapon. So, all you have to do is just add a couple more elements to that, and then a bunch of energy, and in the long run, you'll get a huge amount of what's the word, gross? Is it net or I think net energy or whatever from it, and the explosion would be literally millions of times, hundreds of thousands, if not millions of times more powerful than Tsar Bomba if you were to achieve the production and annihilation of a large quantity of super heavy material. But of course, there's the issue to do with density and what is it? I'm not gonna get into that. That's what I got into the last video I tried to make. I tried to make this video, like I said before, 5 times, and I got into that, and I got too in depth, and it got too complicated. But basically, it requires heavier elements to get more energy, and it requires much more energy to get much more out of it. So that's the problem with that. And then like I said before, the shock waves from thermonuclear explosion, and the heat, the issue to do with the heat. Yeah, and then the other problem with only like a few percent, like a 1 or 2% of the material being converted into pure energy. And then another small percentage being converted into heat, and the rest of the material just flying off into the air. So there's that issue. But if the weapon, I think it's primarily about the materials used and the design of it. The size, the shape, what things go off first, where things are placed. I think this plays a huge role in designing the first super heavy thermonuclear weapon and the first subatomic weapon. And so these are some little findings and ideas that I've had. And so I don't know if you're interested in anything that I've said, if you have any advice, any critiquing, any what's the word, any opinions you want to bring to my attention, definitely comment in the comment section down below, and check out my other videos. I make videos on lots of different topics, but as I've always said, I have a deep fascination in science and technology, so that's partly why I made this video. And so yeah, check out my other videos, and please comment and let me know what you think.